diagram? A small block of weight of 1000 Newton as shown. This is the diagram. This is the block we're referring to. Let's denote the block as A. So this block is placed on a 30-degree inclined plane. They are giving mu to be 0.25. Then moving on, force to be applied. This we are to determine it in different cases. For case 1, the motion of the plane. For case 2, impending motion down the plane. Now, let's list out our data. Given data, we are given mu to be 0.25. We are given the angle here to be 30 degrees. What's the weight of the block here? The weight is given to be 1000 Newton. And the weight, if I'm drawing something like this, we should be familiar with this by now. We have our weight. This is 1000 Newton. This angle, what will be the value of the angle here? 30 degrees. Then we have our normal reaction being R. Now from here, for the first one, impending motion down the plane. Now this is how it works. I said earlier on that for impending motion down the plane, what it means is that this force field that you applied, you applying this force to this block, you want to push the block, right? But from the question now says that impending motion down the plane, meaning that this speed is not sufficient to push this block, right? Now, when this force is not sufficient to push it, imagine yourself being the force that you want to push it. When the force you applied is not sufficient, what happens? It will slide down. Imagine you are on a ramp, as I've said earlier, that stuff that you normally carry your wheelchair on, or in anything slopey, you get. And this is it here. This block obviously is going to slide down. What's bringing it down? Gravitational force. So there will be this force opposing that gravitational force, and that's what we call the frictional force. Meaning, normally my frictional force is meant to oppose it in this manner. I'm meant to have my frictional force in this manner, right? If my force is going like this, frictional force should be like this. But since the question says that impending motion down the plane, meaning the moment your gravitational force is bringing the block down, your frictional force will oppose the gravitational force. By opposing the gravitational force, it means that you have your gravitational force in this manner. Are you with me? Now, you will now observe that the externally applied force to this block and the frictional force, they are going in the same direction, right? Now, what this means in general is that whenever your question says that calculate the motion impending down the plane, it means your frictional force is going in the same direction as the applied force, and that's the concept. Now, let me reverse the case. Let me ask you this simple question. What if my applied force is this? I have my applied force being this guy here, 30 degree. Then my frictional force, I'm still solving for impending motion down the plane. In what manner will my frictional force act? Like this. My frictional force, I'm solving for impending motion down the plane. From what I said generally, when you are solving for questions and you are solving impending motion down the plane, it means your frictional force will go in the same direction as the applied force. Now, observe this diagram. Check this diagram very well. Me denoting my frictional force in this manner, is it correct? It's not correct. Why? Because it has to go in the same direction. So the correct manner in which this frictional force will go is something like this. Are you with me? And that's the concept. Practically, it means that when you have that box that you are pushing up the plane, when the force, meaning yourself, you apply to that box is not sufficient, what will happen? It will bring the box will slip back down, right? What's bringing the block back down is called gravitational force. So that gravitational force, we have an opposing force, and that opposing force is called the frictional force. And that's it. That's the concept. All right, back to the given question. Back to the given question. Now, the given question, this is what I have. I have 30 degree, I have P, and this is my frictional force. And frictional force, mathematically, that's what mu R. Alright, from here, the same concept. Solve for horizontal component and solve for vertical component. Now, let's get this done. From here, for your vertical component, summation of vertical component equals 0. Now, identify how many vertical forces do you have here? How many vertical forces? I'm having this P. Mind you, this P is an inclined force, but I can surely solve it to both vertical and horizontal. So I'll consider it being a vertical force, since I can get the value in a vertical form. You get? So this is 1, this is 2, this normal reaction, this is 2, and this weight itself, this is 3. You get? Meaning that I'm resolving 3 forces to the vertical. Now, for the first one, let's resolve this first one to the vertical. What will be the value? P sine 30. What will be the direction? Positive or negative? Negative. Exactly, negative. For people that just entered, we've explained previously. Now, this is what they did. From here, what you just did here, you just applied the idea of resolution of forces. By resolution of forces, you resolve in the vertical direction and in the horizontal direction. Now, let me bring out this P, meaning I have something of this nature. Let's say I have something of this, and from here, this is P, right? This is 30 degree, this is Y, this is X. Also consider your Cartesian coordinate. Recall from your mathematics, this is your positive, negative, positive, negative. This is the y-axis, this is the x-axis. Now from here, ask yourself, is there a difference between this and this? No difference. I brought this component, I brought it out from this diagram. Now what we did here, me having something of this nature, I'll solve in the vertical axis and I'll solve in the x-axis. Now, first thing first, I have an angle inclined, right? Now, my question for you guys is, where is this angle inclined to? Is it the horizontal or the vertical? Now, your angle being inclined to the horizontal, what it means is that the horizontal components take cos. You know, it is between cos and sine. Now, anywhere your angle is being inclined to, that place will take cos. Why automatically the other takes sine. Now, for this angle is inclined to the horizontal, meaning for horizontal component, I have what? P cos theta degree. Then for y component, being the vertical component, what do I have? P sine theta degree. But you are not there yet. You need to introduce your sign. Is it positive? Is it negative? Now, from here, look at this thing. By the time you resolve this P to the vertical axis, where will it be facing? In what direction? Downward, abi? Now, come back to this case. What is the sign for downward? Negative. Meaning this P is facing this guy here. It's facing this, right? And we have negative here. So this place include negative. Then likewise this, what do you have? Positive. Why? Because this P, it will face here, then this is positive, so you have positive here, and that's the concept. So in general, anywhere your angle is being inclined to, that place will take cos, while the other one will take sine. Now what if we have something like this? Let's say we have our angle here mean 30 degree, then f of y will be what? Let me call this case 1, call this case 2. For case 2, f of y will be what? Minus p cos 30 degree, then f of x should be what? positive p sine 30. I believe you know how it works now. So that's what I just did here. When they told me negative p sine 30, don't be confused. That's how they go about it. You get. Now from here back to the question. Solving in vertical axis for this one, considering this one first, I have negative p sine 30 degree. You know why you need to be a master of this? Because in your exam you don't have enough time. You bringing it out one by one. Under 2 hours you are meant to solve like 5 questions. So spending time on this bringing it out, it will take a whole lot of time. So you need to visualize it on your head. You get. Now I've considered this p first. The next one, this or this, which one should I take first? The up one, which is the normal reaction. Then that becomes what? Just R. Positive R. Why is it positive? It is acting upward. Then for this weight, that what? Same idea, apply it here. Then it becomes what? Minus 1000 plus 30 degree. Then are we done with all the vertical forces? If yes, equate to 0. Then that's it. Then from here you observe that you have 2 unknown. So make either p the subject of the formula or you make r the subject of the formula. Is your choice. Now let's make r the subject of the formula. By making r the subject of the formula, it becomes r. We call this equation 1. Call this equation 1. From equation 1, make r the subject of the formula. That becomes r equals to, obviously this will go to the other side, then it becomes positive. P sine 30 degree plus 1000 cos 30 degree. Okay, let's get the value of sine 30. That's 0.5p plus what's the value of this? Input this in your calculator. What do you have? 866.03, right? Call this equation 2. R equals to 0.5p plus 866.03. That's equation 2. I'm done with vertical forces. Now horizontal forces. Summation of horizontal forces equals 0. How many horizontal forces do we have here? 3. I'm having this, and I'm having this frictional force. Then considering this, use the same logic to solve. There's no time you bringing it out. Now from here the value of this becomes what? In the horizontal direction. We've solved it here already. That's what? P cos 30 degree. I'm done with this. Moving on to the next one. That's what? Minus 1000 sine 30 degree. Horizontal 30 degree. Then for your frictional force, will it be positive or negative? Positive. Force of this nature, positive. Okay, this is it here. Force of this nature, positive. Force of this nature, negative. For the x-axis. Then for the y-axis, if your force is like this, positive, like this, negative. So that's it. Now from here, what do you have? Plus mu r. Call this equation 3. Since we stop at equation 2, you know this to be equation 3. Moving on, we have equation 3, right? Then from equation 3, you can substitute the value of equation 2. See, you know, now the task is me calculating the value of r and p. Right? From equation 2, I need the value of r. From equation 3, I need the value of p. So I can introduce simultaneous equation into this place. Anyhow you are good at it. But here I'll be doing substitution method. Since I know the value of r, the expression for r in equation 2, I'm just going to substitute it in equation 3. You get the point? Yeah, from here, what's the value of your r mu given from the question? 0.25. Meaning that p cos theta is what? 866. 866. Let's stop here. Then this is what? What do you have? Minus 500 plus mu. The value of mu is 0.25. Open bracket, equation 2. 0.5 p plus 866.03. Now open up your bracket, equate to 0. Sorry, before writing equation 3, you are equating to 0. So equate this to 0. Hope there is no confusion. Okay, from here we then have that 0.866p negative 500 plus, open up your bracket, what do you have? 0.125 0.125p plus 2, no, not minus, it's plus. Positive 0.25 times this give us positive 0.125. Positive times positive is positive. Come from the mathematics. Positive times positive, negative times positive, positive times negative, then negative times negative is plus. So you get, be mindful of that, please. Now from here you have that. So now what's the value? 216.51. That's all. This time this equals 0. Now you have the value of p. The variable in this equation, now you only have one unknown. Then you can make that solution to the formula, which is p. This plus this, what do you have? 0.866 plus 0.125. What do you have? That's 0.991p equals to 500 minus 216.51. For the first question, we've solved impending motion down the plane, right? Now, for this, we want to solve impending motion up the plane. The concept is that for the first one, the direction of friction, what is changing now is the direction of friction for the first one is going in the same direction as the externally applied force. The question is why? I've explained what it means, right? Meaning the frictional force in that previous example is opposing gravitational force. You get? That's why we have it going in the same direction. But for this one, the frictional force is the usual one we know. Meaning the block is moving up the plane. Find the magnitude of the force that will push this block up the plane. Now, say you have your block like this. Imagine yourself pushing this block up the plane. By the concept behind frictional force, there will be an opposing force, right? And that opposing force is what we call frictional force. So this is how it's going to act, frictional force in this manner. So you are saying that your frictional force is equals to mu r. We substituted frictional force being mu r. So that's the idea. Now let's solve. Same thing, nothing is changing. You solve for summation of vertical forces and summation of what? Horizontal forces. Now for summation of vertical forces equals 0. Identify. How many vertical forces do you have here? We have 3. We have this, though this is an inclined force, but you can make it to be a vertical force. Sorry, a vertical force. You can resolve the vertical component. Likewise, this inclined force too. You can resolve to the vertical component. Then lastly, we have this being a vertical force on its own. Now let's solve. From here, apply the same principle. You know, the first one you did, you brought this force out. By now, I believe you should know how it works. Now, what will be the magnitude of this force in vertical axis? Minus P sine 30 degree. Now, let's stop. We have this 1000 Newton. 1000 Newton also going in the vertical direction. Now, when we are doing resolution of forces, You are resolving to both x-axis and y-axis. So take this as your vertical axis. I'm denoting it as y. Then take this be your x component. Then assign your positive and negative sign relating it to your Cartesian coordinate. This becomes positive, negative, positive, negative. Now, solving this 1000 Newton to the vertical axis, meaning you are taking this force, you are tipping it to the y-axis. On getting there, the sign is what? Negative. So, meaning you have negative 1000, then 1000 what? Cos 30 degree. Now the question is, why is it cos 30 degree and not sin 30 degree? It is cos 30 degree because the angle given is being inclined to the vertical, right? I've considered this. Then the last one here is what? R, and it is acting upward. Then you have positive R equals 0. So I'm done considering all the summation of vertical forces. From here, I'm having two unknown. I want to get the value of these two unknown, but I have to express one in terms of the other. So in this case, let's express P in terms of R. That is, make R the subject of the formula. Then it becomes R equals to P sin 30 degree plus 1000 cos 30 degree. Call this equation 1. From equation 1, you got the expression from equation 1, resolving for vertical forces. Now, on to the next one, horizontal forces. For horizontal forces, identify how many horizontal forces do you have? 3. You can consider this being your horizontal force. You can consider this as your horizontal force. And lastly, obviously, this is a horizontal force, frictional force. Now, solve this. Resolve this in your horizontal component. What do you have? Positive P cos 30 degree. Right? Now, for this one, resolve in your horizontal. Meaning you are bringing this man here. You are dragging it to this component. On getting here, you have a negative sign. So it becomes negative. What's the magnitude of the force? 1000. Then it will be what now? Sin 30 degree. The question is, why is it sin 30 degree and not cos 30 degree? Because the angle given is inclined to the vertical. Right? Then for horizontal takes sine. You get? That's how you got sin 30 degree. Then for this frictional force, will it be positive or negative? Negative, because we have force of this nature. Force of this nature negative, force of this nature positive. So it's acting this manner, negative. So I can write it as negative frictional force. But we can also substitute it as mu r. So we are saying that mu r equals 0. Now from here, you can substitute the value of mu, which is coefficient of friction, and you can substitute the value of the expression for r from equation 1. Then it becomes P cos 30, 0.866, right? So 0.866 P, this is what? 500. Negative 500 minus 0.25, all into bracket the expression from equation 1. What do you have? 0.5 P sin 30, 0.5 P plus the whole of this is what? Plus 866.03. Close your bracket. Equates that to what? 0. Now, open up your bracket. Then you have 0.866p, negative 500. The product of 0.25 and 0.5p is what? Negative 0.125. 0.25 times 866.03. What do you have? Minus 216.51. Oh, that's true. This time this 0.125p minus 216.51 equals 0. Now subtract 0.125 from 0.866. That's what? 0.741p equals to 500 plus 216.51. Collect like terms. So you have this. Then from here, the summation of this 0.741p is equals to, this is 716.51. Therefore, the value of p